Can ChatGPT tell us the cure for cancer? Yes, it can. Can you believe it? Yes, it can. Welcome to What's Up in Science with Dr. Tetikol. New paper, just in. CancerGPT. We'll talk about this in a second. But seriously, can an AI model, especially a large language model, tell us the cure for cancer? How can it even know something we haven't discovered yet? Or did we? First, let's get one thing straight. Do we know the cure for cancer? Yes, we do. Although we use the same word, cancer is not just one disease. Even when we refer to, for example, lung cancer, it's still not only one disease. There are many subtypes of these cancers which can have completely different etiologies and treatment methods. The overall survival rate, which is defined as 10 or more years after treatment, is 50% in England. This number was 24% 40 years ago. Can you imagine? Today, we are able to save twice as many cancer patients. This number is 68% in the US, probably because it is defined as a 5-year survival rate instead of 10. However, the survival rate varies dramatically between different types of cancer. For some, we're above 90%, for others, unfortunately, less than 10%. The misconception is that cure is an overloaded word. Some people expect magic. You take the pill and you're cured. That's just science fiction, at least today. That does not even apply to simple cold or minor headache. But as you can see, there is already magic happening. And the ingredients of that magic are blood, sweat, and tears of tireless scientists. Okay, with that out of the way, let's get back on track. How can it even know something we haven't discovered yet? Well, maybe we did, but we just didn't realize it. Today, we produce so much science that we cannot fully grasp what we have produced. We publish approximately 14,000 scientific articles per day. So one may claim we don't really know what we know or how much we know. 36% of those scientific articles have 0 citations. In summary, it's almost impossible to grasp the extent of information even in one's field of expertise, and even more difficult to put all these pieces together to form a hypothesis or arrive at a conclusion. Even though we augment ourselves with technological tools to expand our capabilities beyond our physical or biological limitations, think conference calls, multiple displays, or generative AI tools, when it comes to phenomena that we cannot fully describe, like cancer, we struggle, especially when the information is disorganized. For rare cancer types, the knowledge of biological entities such as cells, mutations, pathways, genetic background, and cellular environment is sparse and mostly in free text format instead of structured data. Fortunately, we have this new amazing tool today, large language models, which can sometimes be better than us at seeing the bigger picture because they can incorporate a larger amount of information when making inferences or predictions. The researchers in this paper start from an existing model, GPT-2, and fine-tune it by feeding it the drug pair information for various common cancer tissues. By the way, drug pairs are a combination of 2 or more cancer drugs that show therapeutic effects that exceed the sum of their individual effects. This is called the synergistic effect. After this fine-tuning, the model is further tuned with rare cancer tissue data via a method called few-shot learning. Few-shot learning is when you give the AI model only a few examples to learn from, and then you expect it to put that knowledge to use for prediction. Once all of this process is complete, what you do is actually ask CancerGPT whether a given drug combination will have synergistic effect for this tissue or that cancer type. Results? CancerGPT performs better than the best state-of-the-art solutions for some tissue types. This simply is mind-blowing. The model is able to ingest the scientific information and present us with actionable inferences. In one sense, it's not really generating new information, but putting together the many bits of science we produced and published in the scientific literature. But I don't think that detracts from how amazing this is. I would still call this new knowledge. But hold on, it doesn't end here. There are other advantages to using such an AI model. First, unlike some of those other methods, CancerGPT does not require a large amount of organized data, which simply is not available for certain rare cancer types or tissue types. Second, this is a large language model that you can interact with using natural language. So there is no learning curve to use it. But more importantly, you can ask the model to explain the rationale behind its claims. Seriously, the future is already here. An interesting observation by the researchers is some predictions made by this AI model lacked scientific evidence. Is the model hallucinating, or is it discovering new science that we're not yet aware of? Only time will tell. Would you take a drug that no one tried before and there is no scientific evidence supporting it, except for what the AI model says? Let me know in the comments, and smash that like button and the subscribe button, and see you on the next one.